static electricity. Right, in order to understand static electricity, you have to understand what everything is made up of. And the entire universe is made up of the following things. It's made up of protons. Protons have got a charge, a positive charge. It is made of the universe is also made of neutrons. Neutrons have got no charge. And it is also made of electrons. Now, electrons are very, very small particles. They're negative. And these are the only particles that are able to move. Protons and neutrons are locked up in the nucleus of an atom. Electrons can move around, and it is those electrons that actually cause static electricity. I'm going to give you an example of how we can generate static electricity. Now, throughout the universe, normally there's an equal balance between the number of protons and the number of electrons. For every proton, there's an electron. And here you can see a sample showing a balloon with 4 protons and 4 electrons. In fact, there'd be trillions and trillions of protons and electrons. But obviously, for simplicity's sake, we're just doing 4. And of course, we're made of protons and electrons and neutrons. If you notice, I'm not using any neutrons here because they're irrelevant for this part of the course. So you notice that every proton's got an electron, and that's fine. Now, if you then rub the balloon against yourself, what actually happened is that you would rub off the electrons from one substance to another. Now, the electrons go both ways, but actually more go from the human being onto the balloon. So eventually what you end up with a balloon with loads and loads of minuses on it, and the minuses have been taken away from the human being. The balloon should, of course, actually show positives on it as well, because you can't move the positives. But if you notice, there are 4 positives on the balloon, and now there's 1, 2, 3, 4, 5, 6 negatives on the balloon. So the balloon on the whole has got a negative charge. And when you bring this balloon close to the human being, what actually happens is the following. Because the human being has lost some of its negatives, the human being is now positively charged. And by bringing the balloon next to it, all the negatives on the balloon attract the positive charges on the hair, and so the hair stands on end, attracted towards the balloon. Another example could be like this. Let's imagine we've charged the balloon, so you can see the balloon has got 6 negatives and 2 positives, so the balloon's got a negative charge. If we bring it up towards the wall, what actually happens is the negatives in the wall move away, they're repelled away from the wall, and you're left behind with a positive charge on the wall. Now, because the balloon is negatively charged, it is therefore attracted towards the positive wall, and the balloon will stick to the wall. Some of you may have done this at home as an example. So there's another example of static electricity. You may be asked to know what the difference between static electricity and current electricity is. Well, it's as follows. In static electricity, you charge things by friction. You can also charge them by induction. Induction was what we showed a minute ago with the balloon being brought to a wall and creating a positive charge. That's known as an induced charge on the wall. On the whole, the charges in static electricity do not move. They get rubbed off, but they don't move around freely. And it's the way that insulators, things like rubber, plastic, become charged, and it involves electrons. In current electricity, we tend to talk about cells, batteries, and mains. The electrons do move. They move freely through conductors. They move in metals, and they get involved in electrons. So there is a link between static electricity and current electricity. They both involve electrons, but obviously the way that you get static electricity is through friction, whereas current electricity is not through friction. It's through using batteries and mains. And I think that... Actually, no, a couple of key words you need to know is obviously electrons, that these are the negative particles, the smallest things we know, that they carry a negative charge of -1. Friction is the way we charge things up for static electricity. You need to know that if you've got a positive and a positive, they repel. A negative and a negative, they repel. And if you get a positive and a negative, they attract. Opposites attract is often a phrase that's used here. And that there is everything you need to know on static electricity.